Hello, class. Good evening. You're welcome to today's class. Okay, so we are going to look at a review on the calculation of frictional force. Okay, if you are joining us for the first time, please give it a thumbs up and subscribe to this channel. If you have been here, and thank you for staying and sticking to this channel. Okay, so let's dive into what we have. Addison, you're welcome. How are you? Sokwe, you're welcome. Gospel, Imiete, you're welcome. Please, are you seeing the two lines on the board? Are you seeing the two lines on the board, please? Mbara, you're welcome. Okay. Imiete, I'm not seeing it. Please, is it okay now? Gospel, are you seeing it now? The two lines on the board. Addison. All right. Wachiku Olebube, you're welcome. How are you today? Beatrice, how are you? Christian Andrew, how are you? All right. Before I move into the calculation of friction, I'm still going to explain what is frictional force and what it is all about, okay? We all agree that we said earlier in our previous class that friction is a force of opposition. And then from the laws of friction, the one that says that the frictional force is directly proportional to the reaction force, okay? Then going by that, all right, look at what we have. We have this diagram on the board. This is a lot of fluid. This is a block of wood, okay? And this block of wood is resting on the horizontal surface. And the direction of motion is moving this way. Because friction is a force of opposition, it is moving in opposite direction. Okay? Friction is moving in opposite direction. Alright? So, from the law of friction, the force Frictional force, which is this, is directly proportional to the what? To the reaction force. And what is my reaction force? It's equal to the weight, but it's acting upwards. The reaction force is equal to mass times what? Acceleration due to gravity, okay? Whereas the friction is equal to mass times what? Linear acceleration. So with that being said, we now say that the force is equal to mu what? R. Okay? What is mu? The coefficient of limiting friction. Right? So we have this force to be MA is equal to mu mg. Alright? In case you're asked to find the coefficient of limiting friction, that is MA equals mu mg, right? I divide both sides by what? Mg. Mg, this cancels this. So mu is equal to what? Ma over mg. Okay? Mu is also equal to the frictional force over reaction force. So this is a summary of what we did under friction. Right. Progress, you're welcome. Please, if you are just joining us, I want you to give this video and give it a like. Alice, you are not following. I should repeat. Okay, I'm coming. Please give it a thumbs up, okay? Give it a like. All right, let me go again. I said that this is what? The frictional force we explain. What is friction? Friction is a force of opposition that acts between two surfaces in contact. Now, I have this block of wood resting on a horizontal surface, right? So what do I do? The weight of this block of wood is acting down, right? The reaction is acting up, opposite to the weight, but they are equal. Now, the direction of the motion is this way, while friction, which is the force of opposition, is acting opposite to the direction of the motion. Okay? The law of friction, this says that the frictional force is proportional to the reaction force. Now, that is what I have. What is reaction? Reaction is equal to the weight, and weight is equal to mg, right? What is F? F is frictional force, and frictional force is equal to ma. Ma because it's dealing with a linear acceleration. Now, the force is equal to, I want this proportionality sign to introduce a constant. This is mu r, okay? Now, frictional force is equal to ma is equal to mu mg, right? Okay, so if I want to make it the subject, I'll divide both sides by mg. By the time I divide, I have mu is equal to ma over mg, right? What is mu? F over what? R. It's also the same thing as what? Ma over what? Mg. You understand now better? Addison. Right. Robinson, you're welcome. Norma, you're welcome. Ezekiel, please give it a thumbs up. Are we done? It's not N, it's mu. We represent the coefficients of limiting friction. Are we done? All right. Blessing, you're welcome. Beatrice, you're welcome. Ashikutidera, okay, so we can proceed. Robinson, does it mean when you are looking for mu, you will divide, you will You will become F divided by G. I don't get your question. Normal knows say hi, you're welcome. All right. Robinson said, I mean, you will divide first by grams. No, 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 no. Abbas, you're welcome. Please give it a thumbs up, okay? Thank you for coming. Lemchi, you're welcome. Joseph Progress. Nakuzi Onyeka, you're welcome. Thank you for coming to today's class. Are we done writing? Let's solve together. Okay, you're welcome. Let me set a pool. Once you have not subscribed, so go and subscribe. Okay, let's solve. kilogram lies on a rough horizontal platform. A metal block of mass 5 kilogram lies on a rough horizontal platform. If a horizontal force of N Newton is applied to the block through its center of mass, just slide the block on the platform. Okay? Then the coefficient of the limiting friction between the block and the platform is dash. Now in this question, you should make use of G. G to be 10 meters per second square. Okay? We make use of G to be what? 10 meters per second square. Right? Okay. So we are given a block of mass. So this metal block, the mass of it is what? 5 kilograms. So we go by saying that the mass is 5 kilograms. Okay? Then I have G to be 10 meters per second square. Right? Then frictional force. Frictional force is the horizontal force. Frictional force F is equals to 8 Newton. Now for us to get the mu that we are looking for, which is coefficient of limiting friction, we are supposed to solve for what? We are supposed to solve for reaction force. And reaction force is mass multiplied by acceleration due to gravity. So reaction force is equal to mg. Right? Now what's my force? My mass is 5 times my g is 10. Okay? Then I multiply, it's going to give me 50 Newton. Is that okay? Whereas my frictional force is 8 Newton. So using the formula, this says that what? Frictional force is equal to mu r. Okay? What's my frictional force? 8. What's my reaction force? 50. And I'm looking for coefficient. So that means 8 is equal to mu times what? 50. Okay? Now I divide both sides by what? 50. Then I'm left with what? Mu. Mu is equal to 8 over 50. Right? In the help of our calculator, we divide. Mu is equal to 0.16. Remember, it has no xi what? Unit. Okay? So this is how we can solve this problem under frictional force. Right. Okay, how will you know that you make use of G? Now, if you are given mass and you ask to find the reaction, Gibbs boss, you're welcome. I ask to find the reaction. The reaction is equal to mass times G. Okay? And G is acceleration due to gravity. That's why I told you that the weight of the body is acting down. The weight of the body is acting down. Okay? So you must find the reaction, which is the same thing as the weight. Okay, Chisa should go again. All right. A metal block of mass 5 kilograms lies on a rough horizontal platform. If a horizontal force of 8 Newton applied to the block through its center of mass, just slide on the what? Block. Just slide the block on the platform. Then the coefficient of the limiting friction between the block and the platform is what we are looking for. Do you understand? Now, I now added that G is equal to 10 meters per second square. With that being said, we are given the mass of the block, which is what? Which is 5 kilograms. Okay? And the frictional force, which is something like the horizontal force, is given as what? 8 newtons. Now, how do we get the coefficient of the limiting friction? You can get the coefficient of the limiting friction if you get the reaction. And what's the reaction force? Reaction is mass times acceleration due to gravity G. Right? We know that our mass is what? 5 multiplied by what? 10 to give me 50 newtons. Is that okay? Then my frictional force is 8 newtons. Then with the formula F is equal to mu I. My frictional force is 8 and my mu is what? My reaction is 50. Now, Addison, you said, how do you know when to use G? They've given you the mass of the object, and the mass of the object is resting on the horizontal ground. So we need to find the reaction acting on that mass. Okay? So if you are giving the force of that object resting on the horizontal block, you don't need G. But because they gave you mass, you are working with force and not mass. So you have to convert it to the force by multiplying it by what? By G. Addison, do you get it now? Now you multiply it by G, which is 10, which is constant. You now get this as 50 newtons. Okay? But you just whereby your reaction force is given already, so you don't need to subtract. But if it is not given and you're giving mass of the object, you need to multiply it to get what? The reaction. Do you understand? Okay, so my reaction is 50 newton. I have to substitute. My force is 8. I'm looking for mu. Then reaction is what? 50. By the time you substitute, you get your answer at 0.16. Is that clear? Right. How will you know when we are solving for reaction force? Hezekiah, welcome. Now we are solving for coefficient of limiting friction, and the formula is F equals to mu R. So you need to solve for reaction force first before you can solve for the coefficient of limiting friction. Do you understand? Ma, please, I don't understand. I thought we are looking for. You are looking for mu, yes. Perhaps to get my reaction force, because I don't have reaction. When I get my reaction force, it will not help me to solve for my mu. Ma, how will we know we are solving for friction or reaction? The question will state it. The friction is something as horizontal force. The frictional force is something as horizontal force. Now look at this question on the board. The horizontal force, that is something as frictional force. Okay? We are done with the question. We are done. We are done with this particular question. Addison. Okay, LMG. Gravitational force. No. It's acceleration due to gravity. G, not gravitational force, okay? Is acceleration due to gravity, G, not gravitational force, and G is constant. It's given as 10. Okay, well, we are here. You're welcome. Yes. Addison, mu is the coefficient of limiting friction. Okay? Once you're asked to find the coefficient, you're looking for mu. And if you're given the frictional force, that is F. Horizontal force is frictional force. Okay? Robinson, goodness. You said I should explain again. Have you understood what I just explained? Joseph, you are done. Why are US? Please, Christian, your question is not clear. Can you write it again? Okay, children, I can proceed, okay? Now let me give another example to understand better. All right. All right, copy what you have on the board. No, don't write it on your physics note. You should get a note for this, okay? Not on your physics note. Get a 60 list or 80 list for this lesson, okay? Because anytime we're on break, we are still going to be doing online class, okay? So get a note for it. Okay, you have bad network. It's raining. Okay, so sorry. Are you done writing? Yes, we are looking for Mum here. Okay, Addison, that's what you're looking for. Yeah. You see the same thing, coefficient of friction and coefficient of limiting friction, you see the same, okay? Addison, okay? You see the same. It's just different English that they are changing. You have started on your, I did not tell you to start with your physics note, okay? Please get a note, 80 leaves for it. Because anytime we're on break, we're still going to be learning physics, okay, during holiday. So get a note for holiday classes, online classes, okay? And the frictional force is not given. Yes, you're going to find it too. Heaven, you're welcome. You're looking for Mum, yes. You're looking for Mum, yes. I put on, let me solve. I want to solve this one for you. Okay. All right. Now let's go. A motorcycle of mass 100 kilograms moves round in a circle of radius 10 meters with a velocity of 5 meters per second. Find the coefficient of friction between the road and the tires, and we are giving G. Let me go again. A motorcycle of mass 100 kilograms moves round in a circle of radius 10 meters with a velocity of 5 meters per second. Find the coefficient of friction between the road and the tires, and we are giving G. Now, how do we solve this? Let's set our parameters. The mass is equal to 100 kilograms. The radius is equal to what? 10 meters, right? And we have velocity 5 meters per second. And we have G. Now there's something you must know. This object, which is a motorcycle, is moving around the circle. It's moving around the circle. And once you move around the circle with a speed, we are looking at what? Centripetal force. Because centripetal force is an inward force, okay, that keeps a body in the center of the circle. It's an inward force that keeps a body towards the center of the circle. So the object is moving around with a velocity of what? 5 meters per second, okay? So we are going to look at the centripetal what? Force. Is that okay? Do you understand? Right. Now, what's the formula for centripetal force? The formula for centripetal force is mv squared over r. Okay, now what is my M? 100 times my V is what? 5 all squared, that is 5 times 5. Okay, divided by R. My R is what? 10. Do you understand? This will cancel this, right? Now we are left with F is equals to 5, 10 times 5 times that is what? 25. Now go by saying 10 times 25. I'm going to have 250 Newton. Right? Now, which force did I find now? This is frictional force because it's the force of opposition. As the body is moving, this frictional force is taking it towards the center of what? Of the circle. So this is the frictional force. This is centripetal force. Okay? All right. Now, for us to get the reaction force, R is equal to mass times gravity. And my mass is given as 100. While my gravity is given as 10. Okay? By the time you multiply, what do we have? We have 1000 Newton. Is that okay? Now, I'm using this centripetal force formula to get the frictional force. And this is my formula for reaction force. So what I'm going to do is to solve for coefficient of limiting friction by saying that F is equal to mu R. Okay? Let's substitute the value. My F is 250 is equal to my R is 1000. Okay? So I divide both sides by what? Coefficient of mu, which is 1000. So that this cancels this, right? So my mu is equal to 250 over 1000. So let's divide. My mu is equal to 0.25. Do you understand? Right. Raphael. Okay, Rachel, you're welcome. I hope you understand. Adirichi, you are welcome. Joseph, I should explain again. I should come again. Okay, Chidera. a circle of radius 10 meters with a velocity of 5 meters per second. Find the coefficient of friction between the road and the tires. And we are giving G equals 10 meters per second square. Now, what we have is to get this mass, which is giving us 100 kilograms. My radius is 10, and my velocity is what? 5. And I'm giving G, which is 10 meters per second square. Okay? Now, because this motorcycle is an object which has a mass of 100 kilograms, but it's moving around the circle. As it's moving around the circle, it experiences what we call centripetal force. Okay? And because it's a frictional force that acts in opposition, so it's trying to keep the body to the center of the circle. Do you understand? So the centripetal force is acting towards the center of the circle. We have done frictional force, we have done centripetal force, which is under circular motion. Okay? So you can go through that video to understand better. The formula for centripetal force F is equal to mv squared over r. Now what is my m? My m is 100 multiplied by, and velocity is 5. That is another 5, right? Okay. Divided by my radius is 10. What do? I have to do what? Cancel. So I'm left with 10 times 5 times 5 is 25. When you multiply, you're going to get 250 Newton. This is the frictional force. Because you're looking for the coefficients of limiting friction, we need to do what? Find the reaction force. And reaction is mg. That is 100, which is the mass, multiplied by g, which is what? 10. We are going to get 1000 Newton. And for us to get the coefficient of limiting friction, F is equal to mu naught R. Okay, what is my force? My force is 250 is equal to mu times what? 1000, right? Divide both sides by what? 1000. So what do we have? We cancel. So mu is equal to 250 over what? 1000. Alright? So by the time you divide, your answer becomes 0.25. Why are we using centripetal force as friction? Because it is acting on the body and taking it towards the center of the circle. Do you understand? Centripetal force, as the body is rotating through a radius, it is being directed towards the center of the circle. That is why we are using centripetal force. Okay? Alright. Do we understand? Do we understand? Lemji, that is not why you are here. That is not why you are here. Progress, you understood, Abby? All right. Okay, where are you there? Ella Frank, are you there? Because for you understand, okay? There I got it. And the rich, you are okay. All right. Okay, where you are there. All right. Let's solve. Blessing, anytime we are not giving friction, we should use this formula. Okay, blessing, we are going to use that formula in sub because it was saying something about the body moving around a circle, okay, that has a radius and with a velocity. You now remember what? Circular motion. Do we understand? Do we understand? It's not in all cases, but that particular question has a radius and with a velocity, and they say its body is moving around the circle, so that is why I make reference to circular motion, which is centripetal force. Okay, but this next one I'm going to solve now, the body is not moving in a circle, and we are still going to look for our frictional force and reaction force before we find the coefficients. Is that okay? So copy, let's solve. Okay, ma, please, are you just revising what we have learned in our last class on frictional force? I'm revising what we have done, and I'm still solving differently from what we have done. Okay, and I'm still solving part of the assignment, holiday assignment here. So when you check your holiday assignment, you see this particular question on the board is one of the holiday assignments. Okay, I have solved the first one and this is the second one, so I'm like doing a review of what we have done before, making it to understand better. Do we understand? All right. Are we all right? So let me explain. All right, so let's explain. A body of mass 25 kilograms, sorry, moving at 3 meters per second on a rough horizontal floor is brought to rest after sliding through a distance of 2.5 meters on the floor. Calculate the coefficients of the sliding friction. And we are giving G as 10 meters per second square. Let me go again. A body of mass 25 kilograms moving at 3 meters per second on a rough horizontal floor is brought to rest after sliding through a distance of 2.5 meters on the floor. Calculate the coefficient of sliding friction. Now, for you to be able to solve this, you should know the equations of motion. You should know the equations of motion. Even though you have not done it, I'm still going to review it and use it to solve this problem. Okay? So let's take the parameters. The mass is 25 kilograms. Okay? The velocity, which is initial velocity, is 3 meters per second, and it is brought to rest. It is brought to rest, meaning that the final velocity v is equals to what? 0. When an object starts from rest, its initial velocity u equals 0. But when an object is brought to rest, its final velocity v equals 0. Now through a distance of 2.5 meters. So my distance is 2.5 meters. You know that in physics we use s to denote what? Distance. Alright. And we have g to be 10 meters per second square, right? Now we are going to use this equation of motion. Using this equation, okay, we are going to use this equation. What are we looking for? We are looking for linear acceleration. So we can get the frictional force. Okay? Now, my final velocity, because the body comes to rest, is equals to 0. So this is 0 square is equals to my initial is what? 3 square. Alright? Plus 2 times a times my x is 2.5. Okay? 0 square is 0 is equals to 9 plus 2.5 times 2, it should give us 5. That is 5. Okay, so we have 5a. I'm going to carry this to the other side to have minus 9 is equals to 5a. I divide both sides by what? By 5. This cancels this, right? So my a is equals to minus 9 over what? 5. If I say 9 divided by 5, I will have minus 1.8. And the unit is meters per second squared. Now I've gotten my acceleration. Now, because of this negative means that this is deceleration. Okay? I know that deceleration is when the velocity of the body decreases with time. So this is deceleration, right? Okay. Even though we are not using the negative sign to solve our problem, but you just have to know what it stands for or what it means. Okay, we are causing the linear acceleration. For us to get the frictional force, F is equal to ma, right? What is my m? 25. 25 times my a is 1.8. Remember, I'm not solving the negative sign, but I just have to state it that it is deceleration. Okay? So I multiply. What do I have? 25 times 1.8. Okay, I have 45 Newton, right? My reaction force is equal to mg. Okay? That is 25 times 10 is going to give me 250 Newton. Now, from the frictional force formula, F is equal to mu what? R. Okay? What's my force? My force is 45. 45 is equal to mu what? Times 250. I divide both sides by the coefficient of mu, which is 250. This cancels this, right? So my mu is equal to 45 divided by 250. So let's find out. My answer is equal to 0.18. Did we get it? Do you understand? Right. All right. Progress. You say you are lost. You are not seeing. Let's I see now. Let's I see the board now. I will explain. I will explain. But I see the board now, blessing. You're not seeing the board. Why are you not seeing? Please, are you seeing it clearly now? Please, everybody, are we seeing it clearly? Okay, it's clearly now. Yeah, we'll soon end the class, okay? It's hour 30 minutes. We'll soon end the class. Okay, let me explain again. I said a body of mass 25 kilograms moving at 3 meters per second on a rough horizontal floor, okay, is brought to rest after sliding through a distance of 2.5 meters on the floor. Calculate the coefficient of sliding friction, and we are giving G to be 10 meters per second squared. Now, I said, for us to be able to understand this question, we would have done the equation of motion. Solving the equation of motion. For some of you that have got the equation of motion, they will be able to understand this. Okay? But if you have not done the equation of motion, I'm going to send you a video of that maybe tomorrow to watch it. Do you understand? Now, I stated the parameters. The mass is 25 kilograms. Initial velocity is given as what? 3 meters per second. And you should know that when a body starts from rest, its initial velocity u equals 0. But if the body did not start from rest, the first velocity given is the initial velocity. So this is the initial velocity. Okay? Now this body is brought to rest, meaning the body was in motion and it was now brought to rest. Okay? That means my final velocity v is equals to 0. My u is 3 meters per second. The body is brought to rest my final velocity V equals 0, and my distance is given as 2.5 meters. Okay? Now, I'm giving G to be 10 meters per second square. The essence of these parameters given is for us to get the linear acceleration. Okay? And once we get the linear acceleration, we are going to use it to solve for the frictional force. Because we need to solve for frictional force, we need to solve for reaction force. Is that okay? Now, we have this. This equation. This is one of the equations of motion. V squared is equals to u squared plus 2as. My v is equals to 0. That is 0 squared plus 3 squared plus 2 times a times 2.5. Okay? 0 squared is 0 is equals to 3 squared is 9 plus 5a. Right? Okay, so if I carry this 9 to the other side, it's going to be what? Minus 9 is equals to 5a. Now, because I'm looking for acceleration, I will take the coefficient of what? Of a, which is what? 5. And if I multiply by 5, then I will have what? My a is equals to minus 9 over what? 5. When I divide, I got my a to be minus 1.8 meters per second square. And I said, I got negative, that means I'm looking for deceleration. And deceleration is a negative of what? Acceleration. Okay? Even though we are not solving the negative sign, it's just for us to know the nature of what we got. Alright, for me to solve for frictional force, which is F, is equal to MA, right? My mass is 25 times my linear acceleration, which is A. Linear deceleration rather. I multiply to get 45 Newton. Then my reaction force is equal to mg. Okay? That is 25 times g. G is 10. I got 250. Now, from the law of friction, F is equal to mu r. Okay? So, I'm going to divide both sides. I have I to be 45 is equal to mu times 250. Right? I divide both sides by the coefficient of mu, which is 250. And I got my mu is equal to 45 over 250. And the answer is equal to 0.18. Is it clear? Right. I did not get 295. It's 2as. This is 2as. That is the equation of motion. Gospel, you're not seeing the other end of the board. This is it okay now? Osakwa, is it okay now? Okay. All right. So do I still have questions from this example I just explained? Do I still have question? Do we still have question that will solve? All right, do we understand? Chidera, you understand a bit? AS. Okay, that is 2AS. A is acceleration and S is distance. Okay, Addison. And we are looking for acceleration. We are giving distance in the question as 2.5 meters. Okay. You don't understand the first equation, okay? Okay, so I will explain from the first equation. All right. Goodness, sorry, obedience. The body is okay. All right. Please, if you are just joining us, give it a thumbs up and like this live stream, okay? So let me explain again so that Lem, Chi, and Addison can get it right. All right. We are given a body of mass 25 kilograms at this velocity 3 meters per second, okay? And it's brought to rest. The body was in motion with a velocity of 3 meters per second and it was brought to rest. That means this initial velocity is 3 meters per second. Anything that comes to rest automatically becomes 0. So final velocity is equal to 0. Okay? And it covers a distance of 2.5 meters. Calculate the coefficient of the sliding friction. And we are given G. After specing our parameters, we are using this equation of motion. We are using this equation of motion. V square is equals to U square plus 2AS. Right? V is final velocity, U is initial velocity, A is acceleration, and S is distance. And from this equation, we're looking for acceleration. So we go by saying my final velocity is 0. That is 0 square is equals to 3 square plus 2 times A times 2.5. Okay? Now, this is 0. 0 square is 0. Is equals to 3 square is 9 plus 2 times 2.5 is going to give me 5. That is 5A. Right? Because I'm looking for A, I will take this 9 to the other side. Give me minus 9. Then is equals to 5A. I divide both sides by the coefficient of A, which is what? 5. Okay? Then my A is equals to what? Minus 9 over 5. I divided to get 1.8 meter per second squared. Now, I take this negative sign means I'm looking for deceleration. Okay? Now what I got is the deceleration. But that does not mean you're using the negative sign. It means that the velocity decreases with time. Alright, so let's get the frictional force. Frictional force F is equal to MA. Right? Frictional force, remember, is the force of opposition. What is my M? 25 times my A is 1.8, right? I multiply to get 45 Newton. Then my R is equal to mg. My M is 25 and my G is constant, which is 10. Okay? I multiply to get 250. Now the frictional force F is equal to mu R. That is the formula. Okay, my frictional force is 45. It's equal to mu times what? 250. Then I divide by the coefficient of mu, which is 250. Okay, this cancel out to get me mu. Then what do I have? Mu is equal to 45 over 250, and my answer is equal to 0.18. Do we get it now? Let me check. Do we get it now? Right. All right, it said when there is initial velocity, the velocity will be 0. Then to your question is not clear. Please, can you ask it again? You know, we have two types of velocity. We have final velocity and initial velocity. Okay? But why is velocity 0? Because the body comes to rest. The body started with initial velocity of 3 meters per second. Okay? Now this body comes to rest, meaning that its final velocity u is equals to 0. Now let me state it now. When a body starts from rest, its initial velocity u equals 0. When a body starts from rest, its initial velocity u equals 0. But if a body did not start from rest, okay, if a body did not start from rest, the first velocity given is the initial velocity. Now, this body did not start from rest. It started from 3 meters per second, but it was brought to rest. That means, as the body was making movement, it came to rest. Okay? Now we have two types of velocity, initial and final. So, in this particular question, the initial velocity is 3 meters per second, while the final velocity is 0 because the body comes to rest. Okay? Now, using that formula on the board, that is one of the examples of the equation of motion. Using it to solve. The essence of using that equation is to get our linear acceleration. It will help us solve for our frictional force. Okay? All right. That is what I just did. Peculiar, you're welcome. This is one of your holiday assignments. I just solved it for you. Are we done? All right, Alice, you understand better now. All right, you're welcome. Please, I want to give you one classwork to try, okay? I want to give you classwork to try so that we can conclude. Okay, try this example. Let's see what you're going to get at the end. Please solve, solve, solve. Are we solving? Are we solving? Gerard, you're welcome. How are you today? You're welcome. Thanks for coming. Yes, I'm going to use this to get your reaction first. Gerard, have you subscribed to this channel? Please make sure you subscribe, okay? And give it a thumbs up. Yes, we're using the one we just used now, okay? Yes, just try it. This is the same method. Let's see what I'm going to get at the end of the day. Make sure you are solving. Okay, are you still here? Okay. No, Addison, for you to get the frictional force, you're going to use this other parameter to solve and get the linear acceleration. Okay? You are using G to get the reaction force. Use the same method of what I just did now and solve it exactly the same way. I'm going to get the answer. Okay? Oh, thank you so much, Osakwe. Please try and like and subscribe, okay? Okay, Blessing got 0.417, okay? Let's see. Season of Love TV1. You're welcome. Ma, must we use 2 for this question? Which one is 2, please? Then which one is 2? You're welcome, Season of Love. Addison, there is only one velocity. That was initial. Look at the question clearly. Before coming to rest, once you hear coming to rest, it means its final velocity is equal to 0. Okay? So we have two velocity in this particular question. Do you understand? All right. Okay. Them two are still solving. Also, you got 0.417, okay? Yes, from the previous question, yes. The abbreviation for this is X, small letter S, okay? That's the abbreviation for distance. I hope we are still solving. Gerard, my contact. Gerard. You can send it to you, okay? Okay, Gerald, can you send me your contact? Let me just add you straight. Send your contact. Are we done? Addison, Kewe, Lemchi, Adirichi, are we done? Gerard, are we done? Obedience, are we done? Send me your answers. Okay, I'm still solving. Okay, I'm waiting. Okay, I can put my WhatsApp contact on the screen. Lemchi, I'm not really sure of my answer. Okay, let's have your answer now. Let's see what you have. Okay. Addison, you got 0.416, okay? Then you got 0.9, okay? Joseph, you got 0.6, okay? If the initial is 5, then what about the financial? It's not financial, it's final. Final velocity will be 0. Okay. Ezigwe is asking, is she not on the group? Is she not here? She's supposed to be chatting here. Okay, Ezigwe is okay. Wendy, 0. Okay, Wendy, is she not on YouTube? Okay, Chidera, I got 0.9. All right. Now it's like it's time for me to solve. It's time for me to solve. Let's see what we have. Let's see who and who are correct. Okay, Anozie Mesoma. Noma. Anozie. You got 0.416. Okay, that's beautiful. Yes, let's go 0.6. Okay. Yes. If the initial velocity is 5, then the final velocity will be 0. Okay? It will be 0. Okay, so it's school in Oka. Okay. All right, so let me solve. Let's know who and who that got the answer. All right, let's solve. We are using the same method as the old one. Now, when a box of mass 45 kilogram is given an initial speed of 5 meters per second, it slides along a horizontal floor, a distance of 3 meters, before coming to rest. This word rest, it means something. It means that the final velocity of the body becomes 0, okay? What is the coefficient of the kinetic friction? Now, from what I have, I will state the parameters. My mass is equals to 45 kilogram. This is initial velocity U is equals to 5 meters per second. Then the distance is given as 3 meters, and the body comes to rest. That means my final velocity is equals to 0. Now, what are you going to do? We're looking for the coefficient of kinetic friction, okay? But for us to do that, we need to get the linear acceleration. So I'm going to use this equation. Using this equation, v square is equals to u square plus 2as, right? So my final velocity is 0 because the body comes to rest. That is why v is 0. Is equals to my initial velocity is 5 plus 2 times a times distance is what? 3, okay? Now this is 0 is equals to 5 square is 25 minus 2 times 3 is 6. Okay? Sorry, this is plus. I will take this to the other side. I have minus 25 is equals to 6a. Right? What I'm going to do is to take the coefficient. Sorry. I'm going to take the coefficient of a, which is what? 6. You divide both sides. So we are going to left with what? A is equals to minus 25 over 6. Okay? So the calculator of 25 divided by 6, I have minus 4.167, okay? Meter per second squared. Now we have gotten that. Let us get our frictional force, which is F, is equals to MA. And I said we got minus, that means what we actually got, or what we found was deceleration, because that is when the body decreases with time. When the velocity of the body decreases with time. And also, deceleration is the negative of acceleration. Okay? So we have my mass is 45. 45 times 4.167. We are not putting the negative sign, okay? Let's multiply. So I have 187.515 Newton, right? Now for me to get the reaction force, my reaction force is mg. Now my mass is 45 times my g is 10. I'm going to have 450 Newton, right? From the law of motion, F is equal to mu what? R. So we say 187.515 is equal to mu times 450. Okay? We divide by the coefficient of mu, which is 450. Sorry. My marker. A minute. Few seconds. Let me just fill it up. All right. You are going to divide both sides by 450. You divide by 450. So what do we have? This cancel this. So my mu is equals to 187.515 divided by 450. So let's divide. The answer becomes 0.4167. So my answer is what? 0.4167. I hope you get it now. Right. Oh, sorry, I'm going beyond the line. All right, please, do we understand? Do we all understand? Copy. Let's give you assignments and close for today. If you do, copy. Are we done? Once you go 3.8, 3.8, is it the acceleration? Are we done? Approximate. Rachel, which one do you want to approximate? Rich, you are stuck. Stuck where? Is it the final answer they want to approximate? Rachel, Isaac. You can approximate the final answer to be 0.42. Is still correct? Okay, when you are done. Osakwe, you are done. Are we done writing? Rachel, you are done. You are done writing. I should do a recap. Okay, Mbamba. Oh, sorry. Okay. So you can approximate, okay? To be 0.42, still correct? All right, are we done? So we can take our assignment for today. I should do a recap. If you are just joining us, give it a thumbs up. Okay, I should do a recap. Okay. Okay, she should rewatch the video. Okay, so we can give assignments, okay? All right. So we want to end the class, so we can give assignment and call it a day for today. understand it, I'm going to post it. So you're going to rewatch it again and again and again and again, okay? To understand it better. All right, that is your assignment. All right, copy fast. Let's end the class. Okay, so we are done. Okay, we are done. Addison done. Peculiar done. You submit your assignment on the WhatsApp. You can submit it on the group, okay? Wind is done, okay? welcome, Chidera Nwachukwu. Lemchi, I know you're done. Okay, we're waiting for you. Please, I hope you are subscribed to this channel. Love it, you just come. You say you don't understand. Okay, please, if you don't understand, I'm going to make it public, then you will watch and rewatch it again to understand it, because we have done so many examples. Please, I hope you subscribe to this channel. Make sure you subscribe and give it a thumbs up, okay? Hello, I'm going to go to my channel and rewatch it again, okay, to understand better. Anoze, you're welcome. Eze Kisley, you're welcome. Pekulia, you're welcome. All right, I believe we are done with the assignment. So we are going to end the class now. I will see you next time in my next one. Thank you so much for staying to the end of this class. Like I always tell you, the more you solve physics, the more you know it better. Okay? See you next time in the next one. Bye. Addison, I'm not going to be live tomorrow, but on Saturday we're going to be live, okay? But I'm going to send you a video of what you're going to do tomorrow. Equation of motion. Equation of motion, okay? All right. Bye, girls. See you.